StatsProblems.com was used to create this tutorial, which can help us calculate a repeated measures t-test, but with less calculation than a complete t-test. Let's begin by selecting one of the 25 example problems. The question appears in the blue box. A set of population scores is normally distributed. Mean of the difference scores between related groups, d bar, is minus 1.4. Sample estimate of the population standard deviation of the difference scores, S sub d, is 14. Number of score pairs, n, is 25. Alpha is 0.05. Number of tails is 2. What are the results of the hypothesis test, comparing the sample means of the two groups to each other? Let's step through the solution by clicking on the Next Step button. In Step 1, we calculate the estimated standard error of the mean of the difference scores. The estimated standard error of the mean of the difference scores, S sub d bar, is equal to the sample estimate of the population standard deviation of the difference scores, S sub d, divided by the square root of the number of score pairs, n. In this example, S sub d bar is equal to 14 divided by the square root of 25, which works out to 14 divided by 5, which works out to 2.8. In Step 2, we calculate the t-value of the mean of the difference scores. The t-value of the mean of the difference scores is equal to the mean of the difference scores, d bar, divided by the estimated standard error of the mean of the difference scores, S sub d bar. In this example, the t-value of the mean of the difference scores is equal to minus 1.4 divided by 2.8, which works out to minus 0.5. In Step 3, we find the critical t-values. There is no previous evidence, or previous evidence is inconclusive. The rejection regions are below the negative critical value in the lower tail and above the positive critical value in the upper tail. We need degrees of freedom to look up t critical value. Degrees of freedom equals number of score pairs, minus 1 equals 25, minus 1 equals 24. With tails equals 2 and alpha equals 0.05, we need to look up critical value for df equals 24. Use interactive table 7 to find critical value. With two tails and alpha equals 0.05, and df equals 24, use t equals 2.064 from the table below. Negative critical value is minus 2.064 and positive critical value is 2.064. We close this window to return to the analysis, which shows the negative critical value is minus 2.064 and positive critical value is 2.064 with two tails and alpha equals 0.05. In Step 4, we test the hypothesis. The t-value of the mean of difference scores, minus 0.5, is between the critical values of minus 2.064 and 2.064, so we fail to reject the null hypothesis. In addition to the 25 example problems, we can work step by step through an unlimited number of new problems using the Generate button. The Edit Data button can help us create problems with customized input. Instructors can use this function to create problems with complete solutions to use on exams, in class, or for homework. For printed output, we can print the question. Or we can print the question with the complete solution. The free website has statistical analyses in all of the most common areas in statistics. StatsProblems.com also has a mobile version so you can access the site from anywhere. For help with statistical concepts, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. In addition, HelpMeWithStats.com gives you free access to a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share StatsProblems.com and HelpMeWithStats.com with your friends and instructors.